2, 3.
What's up, team? Today we're talking about parallelograms. Parallelogram is a quadrilateral with both pairs of opposite sides being parallel. Here's a couple examples. Here we have parallelogram A, B, C, D, where opposite sides are parallel to one another. We have two distinct pairs of parallel lines that are opposite one another. Remember, the single arrow means that these two are paired up. The double arrow means that these two are paired up. A second example, parallelogram JOSH. Opposite sides are parallel here as well. It's just oriented a little bit differently. Let's explore a few properties and wrap this up. First, consecutive angles are supplementary, meaning, in this case, angle B and angle C are supplementary. They add up to 180 degrees. That's not just a magical fact. We can lean on prior knowledge to see this. If we have two parallel lines and some other line acting as a transversal, these two angles, angle B and angle C, would act as same side interior angles. And if we think back to when we explored parallel lines, transversals, all of this, same side interior angles are always supplementary. So there's a bunch of different examples up here, but we can say for this one here, consecutive angles being supplementary, the measure of angle B plus the measure of angle C equals 180 degrees. That is one example. We can also say angle A plus angle B are going to add up to 180 degrees for the same exact reasons. Now we're leaning on these two parallel lines, and line AB is acting as our transversal. So we'll capture that one here as well. Measure of angle A plus the measure of angle B equals 180 degrees. There's some fun substitution stuff we can explore here in a bit as well. Okay, property number 2. Each diagonal divides the parallelogram into two congruent triangles. So let's see what happens here when we drop in a diagonal line in our parallelogram JOSH. When we have that diagonal in here, we're going to again explore some of these transversal angle relationships. We have parallel lines that are opposite one another. We have a transversal. So these alternate interior angles are going to be congruent to one another. And then similarly, these alternate interior angles are going to be congruent to one another. So we can see here, we have two congruent triangles by angle, side, side, and then angle. That's not true. Not angle, side, side. Angle, side, angle, angle, side, angle. We know angle, side, side doesn't work, but these are angle, side, angle. So, for example, for property number 2 here, we could say that triangle, let's name them JOH, is congruent to triangle SHO. Triangle SHO. Remember, the order in which we write those letters is super important. This is saying that vertex J corresponds to the vertex X, S, O, and H, and then H and O. And we can see just the way that they're marked. This angle O up here has 1, as does this angle H, angle SHO. Okay, hopefully that's clear. Let me know if you have questions about how the notation there. It's in previous videos as well. This isn't the notation video. Next, opposite sides and opposite angles are congruent to one another. This one just really leans on property number 2 and CP/CTC, where corresponding parts of congruent triangles are congruent. Again, we've studied this in the past. If these two are congruent triangles, then all of their corresponding parts must be congruent, meaning opposite angles are going to be congruent. So these angles are congruent to one another. And then we can even go as far as to say that angle O and angle H, those are going to be congruent to one another. Of course, this middle line here is congruent to itself if you're looking at the two triangles. But we can also see that this side, JO and SH, are going to be congruent side lengths, as are OS and JH. Again, we're just exercising some CP/CTC here. But you can figure all this out without creating the triangles. This is going to be true for every parallelogram ever for this reason, so you can kind of skip a few steps here. Opposite sides always congruent to one another. Opposite angles always congruent to one another. I'm not going to write the statements out. You can see in the picture here. Lastly, the diagonals bisect one another. Always going to be true. So let's go back up to this parallelogram, draw in our diagonals. What we have here Really, we're leaning on the fact that these opposite triangles, now we have 4 triangles in here, opposite triangles are going to be congruent to one another. For similar reasons as earlier, we can see pretty quickly they have vertical angles, and then we have these alternate interior angles. I should double this up. Double that up. And then, so we have angle, angle, and then the third angle must also be congruent, of course, because if 2 are, then the last one is. Also, we have alternate interior angles. Angle, angle, angle is not enough information to say these triangles are definitely congruent, but we know that opposite sides are definitely congruent based on what we just talked about with property number 3. So now we're in a situation where we have angle, side, angle, angle, side, angle. You also could say angle, angle, side, angle, angle, side. There's multiple criteria that are at play here. It boils down to the fact that they all work. So this smaller triangle is congruent to the one opposite of it. Now, that's not the property that we're discussing. We're talking about the diagonals bisecting each other, but this property leans on what we just chatted about because, again, using CPCTC, this segment must be congruent to this segment, and in the same way, these two must be congruent to one another. So what that shows us is that the diagonals bisect one another, and that's going to be true for every parallelogram ever. Now, you don't necessarily have to draw it all out, prove that the triangles are going to be congruent like this. I just did it for you. It's going to be true for every parallelogram ever. So it's important to understand that this is true. It's more important to understand the why. Check the video out again if some of this wasn't clear. Let me know if you have questions. Let's check out those practice problems. You got this.